Okay, here's the first example for predicting acid-base reactions. So spilled oven cleaner contains aqueous sodium hydroxide and it's neutralized with vinegar. Write a balanced acid-base equilibrium equation. So just like we did with predicting redox, step 1 is to list all entities present. Sodium hydroxide, we're going to separate into the ions. So we'll have Na plus aqueous and hydroxide aqueous. Vinegar is a common name for one of our acids, which if you take a look on page 9, page 8, 9 in your data book, acetic acid or ethanoic acid is actually the name for vinegar. So because it's a weak acid, we don't separate it into ions, we write it in the molecular form. So CH3COOH, acetic acid, another name for vinegar, is added. So we've got our species listed here. The thing is though, if it's aqueous, we have to remember to include H2O liquid. Now, step 2 and 3 is find your strong acid and find your strong base. So when we're looking for strong acid, we're looking on the first column, which is the acid formulas. And we start from the top and scroll down until we see the first one of those species listed, which in this case will be our acetic acid. So this is what we're going to list as our strong acid. Then we start from the bottom of the other column, so our base column, start bottom up until we see our first base. And in this case, hydroxide is right at the bottom. So this will be our strong base. So we're done up to our third step. Now all we have to do is put this in an equation form. So hydroxide, aqueous, reacts with acetic acid. My acid transfers a hydrogen, so bases steal hydrogen, and this will give me H2O as a product and an acetate ion with a -1 charge. Finally, we have to indicate if products or reactants are favored. And if we go back to our table, since our acid, which is way up there, is a lot higher than hydroxide when the acid is above the base, this is a greater than 50% reaction, so products are favored. So we would want to include that, greater than 50%, to show that this is favoring the forward reaction.